All right, class, we're going to get started here. 4.2. Here's homework questions that have already been asked. Let me change pins. Let's see if this works better. Oh, God, 17, 31, 41, 43. Any others? Going once, going twice. Sold. Okay, let's jam. So 17 it is. We are going to graph y is equal to sine, ooh, interesting, pi over 2x. There's our little fun problem there. And we are to graph one period. That's cool. Okay. I like that when you graph one period, because then you can scale your x right then and there. It's cool. So amplitude, first things first. Amplitude is going to be 1. Everybody agreed there. Period is going to be 2 pi divided by pi over 2. How fun is that? And if we do that, that becomes, if we put in all in as fractions here, right? So 2 pi converts into 2 pi over 1. Pi over 2 stays as pi over 2. And we are going to keep this exactly the same, change to multiplication, and take the reciprocal of this guy. And yes, pi's are gone, and we're left with 4. Yes, whenever you have pi.
Weird that that ended up being 4.
That's why.
Gotcha. So once you're in that, now you're in real numbers. So 4 days, 4 minutes, 4 seconds. What's the cycle for
So when
this?
you have pi in your function, doing like the sine of whatever, then it's a real number.
Yeah, because the period's going to cancel that period at 2 pi is going to cancel it out somehow.
It's just pi, it's there too. Yeah.
So at this point, that is so cool. Let's go with it here. So go out to 4. And if you want to, you can actually scale it now to be like a regular x and y if you want. Because you have now 1, 2, 3, 4, 1, 2. If you wanted to, you can scale it like this. Because now you have just an x and y grid like we normally have. All right, so we have ourselves a 4 is the end. It's the sine curve, and in our mind, sine of x goes like this. And so that means that's here. It always starts off at 0, 0 anyways. It goes up to the top for the max, back down to 0, back down to -1, and we have ourselves.
Yeah, pretty much everything is graphing.
No, but I mean, there was some way only have the period and the amplitude.
If 17 is graphing. I mean, our graph did.
19 was the graph.
No, it wasn't. 19 and 21 were not graph.
Yeah, 1921 was actually looking at the graph going backwards.
That were.
I'm surprised you guys didn't have questions on 19 and 21 because we went backwards on those. You guys are okay with those?
Yes.
Okay, so we got the backwards process. Okay, there's one period and we got it. It's graph. 17 is done. 31. Hey, look at that. Sine of pi over 2x again. Okay. Period or amplitude is going to be the absolute value of that, which is 1/2, which means it goes up and comes down 1/2. Period is exactly the same thing that we just did last time here. So that guy has to become a 4. Okay, I'll show the work here. This becomes pi over 2 pi over 1, multiplication, reciprocal. Pi's are gone, and a 4. And then
4, can you also multiply the both sides by 2? So you get 4 pi over 5.
to get to where? 4?
You multiply the top and bottom by 2 and cross out the
We have to multiply by 2 and 2. Yeah.
Yeah, we can multiply the top, yeah.
Reflection, absolutely. Reflection across the x-axis this time. So we're getting to the point that we want to be able to graph this in one single way. If you needed to do it twice, that's that's fine. Just pull dots and then do the next dots and then connect. But eventually want to be able to graph it in one single set. So 1, 2, 3, 4. Okay, and my sine curve in my sine curve goes like this. So then I already know what's happening here. So what happens here is I have a flip of it. Now it's going like this. And then I know it's only going down to -1/2 and up to a +1/2. So it starts going down. Now let me put in the period. Period is a period of 4. So now at this point I got a 0 here, 0 here, 0 there. If this is 1, that's -1. That means I have my next dot is right here. My fourth dot is here. Before I get to the end, are we good there? Yeah.
You know that there's a reflection because you start with an negative?
A reflection is just because of this guy right here.
Okay.
So then we go down, up, down, and complete. Okay, 31 good. Okay. Dun, dun. We have 41, 43. Let's jam with this one here. They are honor questions, but they're kind of fun to look at here. So the electricity problem first. So the current in alternating circuits, which is what we have, varies in intensity and time. If I represents the intensity of the current and T represents time, the relationship is like this. Where it is measured in seconds. T is measured in seconds. Find the maximum value of I and the time it takes for I to go through one cycle. So it doesn't say graph it, so that's kind of nice. So I guess kind of thinking through the process here. What is the maximum value this guy can reach ever?
Is this Y value basically?
It's the Y value,
Oh.
20, absolutely. Because this whole thing right here, the highest this guy can ever go is 1, right? And so 1 times 20, 20. Intensity of 20. That's that one. And then what's one complete cycle? One cycle period that is saying the same thing.
How do we find one?
So we got ourselves 2 pi over 120 pi. So pi's are gone. And then 1 over 60. There's our one cycle. So it takes 1/60th of a second to cycle up and back on a current. So technically what's happening here is when you watch TV, the screen itself is actually turning off and then turning on and turning off and then turning on. It just does that 60 times in a single second.
But the interesting thing is that there's only 3 different types of colors. It's really good to shade it differently. Because you zoom in on any screen close enough, it's going to be what red, white, and green. It's also how dead pixels happen. It's just when that pixel doesn't turn off, so it just stays as one color.
You're true, yeah. It's interesting how things evolve, and we think of it differently, right? We think we're watching a movie, right? We're actually watching flicking of pixels, but we think, and then I always find it fascinating watching a 2D screen, but you're thinking about it in 3 dimensions, right? Because it's a flat screen, right? But our minds naturally go into a 3-dimensional space.
That's also why with older cameras, you keep on zooming in, there's no loss of detail, but with like a TV screen or a digital photo, you're locked to the resolution. You'll have to go down, you can go down to the pixel in a digital photo, but in like a film photo, you just keep on zooming in. There's no loss of detail.
Very true, yeah. Oh, yeah, we had a photographer that knew our family quite well. He did not like digital cameras at all. It's like, no, I went old school because of that, because I can zoom in. I'm not going to lose any image quality whatsoever if I want to crop it. That was cool. Okay, are we good there with 41? 43. 43 now deals with, oh yeah, maybe you guys seen in physics here, the oscillating spring. So we have something here. We have a spring that's coming down and a certain weight, and that's in rest position. And then someone takes it and brings it down to this position, and then let's go. What's going to happen to this guy? It's going to go up, right? And then come back down, up and come back down. And
Doesn't
then
it slowly get less though?
very good, absolutely. So you're going to go like this, right, for the while. And then eventually, yeah, eventually it's going to go. So we don't, let's see, it's called dampened simple harmonic motion. And we don't, in trig, you could do it. It's almost like, when you guys study this stuff in class, right? I give you like the basic principles of things, right? And then to actually go out in the real world to actually do it, you just need something a little tiny bit extra, right? So this one's same thing here. This is like, okay, this is oscillating spring. The motion for it is, in terms of, here's my calculation, but in the real world, you're gonna have a dampened harmonic motion. You're gonna have to account for that small little tiny variation. It's usually very small. So you have to figure out what that is. Okay, the displacement of the mass from its equilibrium position is given by this function. So 43, d is equal to negative 3.5 cosine of 2 pi t. There's that pi again, where d is measured in terms of centimeters. So the distance away from the distance away from the equilibrium point. Interesting. Okay, let's go with it. Let's try to graph this. Let's see what's it saying. What's it doing? Amplitude is 3.5. Period is 2 pi over 2 pi, which is just 1. That's cool. And do we have a reflection? Absolutely. Reflection about the x-axis. Okay. Can you guys, real quick here in your mind, can you guys kind of graph that real quick here? Amplitude, reflection, and a period. And the only thing kind of just sort of cycle back in our minds is, what does a cosine curve look like? It starts high, ends high, right? So if I have a reflection about the x-axis, that means I'm looking for starting low, ending low. Then I'm also thinking about it's going down to negative 3.5, up to 3.5. And it happens in a single second. So I'm going to go 1, 2, no, hold on. Yeah, I'm going to go 1, 2, 3, 4. Here, this is just going to be 1 for me. And this one, I'm going to scale it a little differently. I'm going to go 0.5, so this would be -1. Oh, sorry. No, I didn't want to do that. This has to go all the way up to 4. Oh, sorry. So 1, 2, 3, 4. 1, 2, 3, 4. There. Okay. Hopefully you guys got to this point. I can put this dot here, here, up here, down here, and then way down here. Boom, there it is. I got it all in one single shot. Cosine curve. And try to make them look like V shapes. I'm sorry, not like V shapes, but U shapes. And make sure they come off of a curve. Okay. So it looks like, as the guy, let's think back to what it has here. So the person is holding it right here and just lets go. Boom. So it is negative 3.5 centimeters below its resting spot. And in a quarter of a second, it goes back to the resting spot, and then it goes higher than the resting spot, and then comes back lower. What is the furthest distance of the mass from its equilibrium point? So that's A. What's the furthest distance? 3.5 centimeters. How long does it take for the mass to complete one oscillation? All yours?
So it's just like rephrasing the amplitude period.
Mhm.
Which is what we do.
Yeah, well, yeah, just if you don't know that.
Oscillation, one oscillation or one period becomes 1 second. Okay, good there. All right, that was the honors question, 43.
For the K thing, but then or no, what was it? It was AA.
I think I did it in my calculator. Like,
Oh,
you
no,
did
it was
sine of x plus 1.
AH minus K plus, like that formula, is that how
Uh-huh.
we start out with?
Let's
one
go with it
part
here,
and then
yeah.
we added more to it?
Oh, no, that was a big formula.
Okay, that was actually nice.
Okay, let's go with it here. So we're going to say y or f of x, if we think about it as a function, we're going to say that a is right here. A is going to affect a certain stuff. Sine of, and then this one's going to be bx minus h. Do you guys remember the h stuff again? Plus k. Now, the way the book writes it, I don't like the way the book writes it. It puts the k in front. Always. That's no fun. You have it like that.
Oh, I do remember this, H and K, and I hated that.
There's h and k.
No, it was just like there's no problem solving, just if you understand the formula and know where it goes.
That's true. I just never figure out H and K.
I found a YouTube video that was really helpful. I forgot after that.
Let me write both of, let me do this here. I'm going to write it two different ways. We'll do it two different ways. We'll vote which one we like best. Okay. So there's that. That's for sine. We got to do for cosine. Notice it's the exact same thing. Notice the b is a multiplier on the outside of all this. Notice the h is actually a negative h. So now let's put all these things together. Amplitude is the absolute value of a. Period is 2 pi divided by b. And here's the new stuff. We have ourselves a phase shift. Phase shift just means horizontal translation.
That just sounds good. I can phase.
H.
Oh, I think I'm saying real life.
No.
I'm sorry.
In like fiction, but it is cool.
Okay, so that's one way to do it. So shifting just means we move dot by dot over, right? So we're going to move dot by dot over either up or down, left or right, or combination of any one of those both two. Okay. That's one way. That's the way the, let's see, kind of like what the book does. Notice the H and K are outside. It's a multiply. The B, we have to factor out the B out of it. We're good. So that's the first like major step we got to sort of think about. How do we factor the
H
B
is
out?
this way, K is this.
Uh-huh.
H is this way, K is mental.
And it's a minus H, exactly the same way. We're gonna just move it the way it was.
Ooh, minus is the horizontal line. That's how I remember.
All right. That's, and he was still finishing up writing there. So wait a little bit. Cool. Let's see, what's the other stuff? Yeah, let's do it this way maybe. Okay, if we go back to our drawing parabolas real quickly here. There's we've been doing this all this time, right? Phase shifts, we've been doing this. Go back to algebra 2. We should recognize this, x squared. We know how to draw x squared, right? It's a,
Problem I got on the oral one. Are we doing that oral one too?
Can we do our presentations not during final week? I
Uh-huh.
think I said that already.
Yeah, I should bring the presentations for us to think about during,
Should I do Wednesday? Assign to it today.
No.
real quick, like, you guys don't need to draw this after me, but I just want to just make sure we got this here. X squared, everybody agreed it graphs like this? Cool. And then if I do this, x squared minus 3.
Goes down 3, right?
Oh, I do have graph. Da, 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 da. Awesome. All we're doing is going down 3, right? Because that minus 3 is all been on the outside of the function. It's not part of our function itself. So we go down 3, each of those dots that we made on the previous slide, and we are good to go. If we have x squared plus 1, we go up 1 from the original graph and done. So we're gonna do the exact same thing with trig functions here. Let's go.
Sorry, can you go back real quick?
Yeah.
There's like 2 things on the other, what was all the.
Oh, yeah.
formula things.
No. Oh, yeah. I know. It would be, if it was parentheses, x squared minus.
Yeah. It's inside. Are we, is there such a thing as sine of x squared?
So when you say phase shift, you're talking about
Oh, we
Algebra.
have to do that?
shifting left to right?
Say it again?
Phase shifting is left to right.
Yeah, phase shift is left to right, and vertical shift is
Differently from the other one. When you say if it's negative h, isn't that actually going?
to the right. Mhm.
Yeah, okay. Cool.
Yeah, absolutely. Same rules apply, same everything.
I can do that.
We're willing to draw the arrows, that's.
All right, let's jam. So again, just connecting to algebra here. Minus 3 goes down, plus 1 goes up. And so let's go with ours. Example 1, y is equal to 3 sine of x plus 2. That's all we're gonna do. Graph this for me from 0 to 2 pi. That's what we need. So what we usually want to do is why 4.2 is different from 4.3, different sections. We want to do the amplitude, period, and reflection first as one piece. Once those dots are in place, then we move it according to the shifting.
You don't just do it all at once.
You could do it all at once. If you can get to that point, that's perfect. Most students just need 2. And if it gets complicated as well, this one's probably pretty easy here. Period is 2 pi. Everybody okay with that? And do we have a reflection? No reflection. And so think of in my mind, sine curve goes like this. So normally it's done in 2 stages. One, two, three, four, one, two. Okay, the other issue is scaling your y value. Because if you're moving up by 7, then you got to think about how high does it go. In fact, let's talk about this here. How high is this graph going to go?
5, right?
It's going to go to 5. Everybody okay with it going up to 5? Highest, this 3 sine of x can go is 3 plus 2 more. So I need an extra little piece here.
Ever go like super big, can you just like label by 2 on the y-axis, like 2, 4, 6?
Oh yeah, absolutely. All right, that it goes up to the highest is 5. So let's do this here.
Oh, boy, that's.
You're gonna sing for us.
Oh, it's doing that.
All right, max is 5. Minimum is -1. So the only thing that would change is the.
So does it ask for the maximum and minimum?
It's not, but first to scale my y value, I need
Oh,
that.
yeah.
So I'm just doing scale my y value. Okay, So then let's jam. I'm gonna do it in 2 stages because it gets complicated. We're have to do it 2 stages here. So sine of x, I got that. It goes up to 3 initially, period of 2 pi. So that's cool. Sine of x, first dot is here. 1, 2, 3. Second dot is here. Third dot, 1, 2, 3 down. And there's my initial dot. I'm not gonna connect these guys. We're good. They're just my dots. Then I'm gonna do any phase shift or I'll take purple for the day. Or vertical shift, and yes, each one of these dots gets translated upwards by 2, and now I make the dots a little bit bigger, just so they're more pronounced. 1, 2.
Instead of doing in 2 phases, could you like, if you know it's moved up 2, could you like draw a new, like a dotted line at move 0, if you will, like at 2, and then just draw this stuff in or something?
Absolutely.
Yeah, same.
I just drew that.
Well, that is, okay, even though it's not like
Another way to do it is just graph it like it's at 0 and then draw the axis here.
that.
Sure. We're down, yeah, go down on the axes. Yep, but eventually, as long as you match what's in the back of the book, that's what we're looking for. There it is.
I just copy it from the back of the book.
Okay, one for you guys, all yours. Again, exercise 2. Can you graph for me? Very similar. I'll give you guys some time here. Oh, you know what? No, let me change this to what?
Oh, wait. I see what you did there.
Okay, give you guys a little bit of time, maybe like a minute or so. Try it yourself.
Oh, God.
All right, just want to make sure that we are graphing 1 period, right? One period in this process. Okay, Isabel, what did you ask for?
Is that just negative factors on pi x, or is that not?
-5 what?
-5.
Oh, got it. No. Sure, yeah, thank you so much. Yo, sure, yeah. So -3 is sitting there in front. It is minus the 3.
Oh, no, you can't subtract.
You can't subtract because they're not like terms.
It's 2 cosine of 2. So it's just saying it goes, it starts with 3, 15. It's also negative 2 over 5. Oh, okay.
Good. Okay, I can rewrite it like this. Maybe this will help out.
Yeah, that's a lot of- Yeah, that's-
I could have written it like this if I wanted to.
Two, and there's a, hold on, vertical shift.
There was that one game we played where you said only the first three to get the answer gets it.
I don't know.
That's what made it fun. 'Cause then you had to-
I hate speeding through that.
Exactly. Then you make mistakes.
Amplitude is 2. We're gonna go up and down 2 units away from the center. Period. Period is 2 pi divided by pi. So I was looking at the answer already. I'm thinking about the answer. Pi's are gone. I get 2 seconds, 2 minutes, whatever it is. And we have ourselves a reflection. Absolutely. Okay. Max value. What do you guys say?
Value 2.
And sometimes min and max might get a little bit mixed up here.
What can we?
Is it maximum?
Maximum get negative. Are we adding in the
No, it's higher the total on then y value.
phase shift and vertical trend? Are we adding that in the negative maximum or do that first and then?
No, we do that first, just kind of thinking about the fact that, oh yeah, the vertical, we're going to talk about vertical translation. That's what we're looking at.
Yeah, so the maximum would be -1 and then -5.
I'll go with that here. Everybody okay with -1 and -5 on here? It's almost easier to do the minimum or the maximum, depending on how they're shifted. And then you can always, the other way to do it is find one of them and always double this to go up or down, right? Because you know you're 4 away somewhere. So in this case, minimum is probably the easiest one to do -5, and then we'll go up by 4 to make a -1. Okay, if you can graph it all at once, that's terrific. Go for it. If you need 2 stages to do so, that's awesome too here. So I'm gonna go like this. And notice my scale
Yeah, it's like a formula.
Yeah, notice my scale for the X and the Y are really different from each other, right? So I'm gonna go all the way to -5. 1, 2, 3, 4, 5. 4, I really don't need the tops anyways. Let me change pin color. So this is cosine curve. Oh, I gotta think about cosine curve. Starts off like this. With the reflection, it's gonna start off like this. And with a with a -2 here. So initially it's -2 to +2 initially. So let's see if I put in my correct dots. Boom, 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 boom. Are we good there with my initial dots for cosine? And 1, 2, 3 down. Translate them down 3 units each time. 1, 1, 2, 3. 1, 2, 3. 1, 2, 3. And 1, 2, 3. That's probably a little high there.
Our text is gonna be like all of this, isn't it? Yeah.
Oh, is this not one of the other? Did you want the test correction grades on for all test grades?
I have not yet, no. I've been dealing with, dealing with college meetings and college finals. So I'll do that early next week.
Do you advise anyone to use that?
Not this year.
It's not like good, like it takes a lot of time.
Yeah.
Oh.
Very true.
The first week that we come back, we have like the word for the presentation.
I'm gonna give it to you on Wednesday.
Okay.
So I want you guys to start this
right
week.
in the semester.
See again?
Is it just due right in the semester, or can we just do it as soon as we have it?
As soon as you have it, yeah. So you can, as soon as you come back, we'll take turns through the, yeah.
So a couple of days.
And we're going to have.
Except actually.
Wait, so we're gonna have not a chapter test, right? It's just gonna be included in the final? Or like chapter 4?
I'm debating here. Let's see. Let's see.
I would rather
If
have
time
it
runs
by
out, then we'll
office.
just have it
Well,
included.
okay, no, because
And if it isn't, then we'll do
if we
it.
come a chapter 4 test, it's just like the stuff, that's just a grade bounce right there.
Or grade wrong.
Yes, but this stuff in my opinion is easier than last chapter, which none of us did super well on.
Dylan, do you really want to have 2 tests in 2 weeks?
Well, Isabel, it would be 3 tests, paired with the 3 chemistry tests, paired with the history class. Yeah, maybe, right?
Yeah, I'm just coming up with taking these tests,
Oh,
because I don't
what
want
is
to.
that, bro?
Oh, so off to the side.
Yeah, hold on, hold
It's
on.
a little bit of
Hold on.
torture here.
Wait, is pi over 2?
You guys got comfortable, huh?
Pi over 2 down?
I have two spaceships.
No. So that's pi over 2 to the left.
To the
Why?
left. Uh-huh.
I guess your period is
No.
still in,
Spaceship.
well, your period is still in pi, so it's fine. Okay, we're good.
Okay.
No. Still just too high.
Uh-huh. So amplitude
Just going back.
is 1.
Oh.
Period is 2 pi
What is it?
divided by 1, which is still 2 pi. No reflection, don't need to do that. Minimum, maximum, I guess I can do that. Which is 1 and -1. Still, is that right? Yep, I think so. And let's go with it. So this is a cosine curve.
Reflected sun.
Ooh, interesting.
I just drew that one other one.
Wait, what is the X in the? Wait, I'm confused. What's different about this one?
Pi plus 2.
Pi over
spaceship,
2.
So it moves to the left.
Oh, yeah, okay. I was confused. I was like, it's the X is what it's supposed to.
Oh, yeah.
And so if we do this real quickly, we say cosine. Let's see if for this we can write out a little easier. X minus a negative pi over 2.
So one rotation is still 2 pi.
So it just moves half of by half.
Yeah, because then it looks like a reflected sign. That's the piece that went that way.
Oh, so it's just.
We're just doing one rotation.
It is
So
one
we
like
just be like this. So you just kept going.
No, that's one. This though is what went that way.
All right, let's go with it here. So we are moving to the left or to the right?
That is negative.
We're moving to the left, is that right?
Yeah.
Moving to the left, right? Okay, let's go 2 pi. We go pi over 2 is here. We have 3 pi over 2. Now with this one, we're going to do is we're going to go this way as well, right? Because we're going to go backwards, pi over 2.
Do we have to go backwards portion? Because it's just, you're still drawing the one period.
As long as you draft one period, yeah, I'm going to just show it one way.
Because it makes no sense though.
I'm going to show it one way, and that's the way because it's just moving the dots the way the book does it. So if I do this here correctly here, original cosine for me goes like this. And there has not been much movement to that, right? It's just still the same. So this is 1, this is -1. Let me change pen color. So cosine would be here, here, down here, a little bit up, back to here. Here's my little cosine curve. Maximum being 1, minimum being -1. And all I'm going to do is I'm going to now translate this pi over 2 to the left. So this guy goes here, this guy goes here, here, and here. So I have now graphed one full revolution of cosine. So,
Okay, that's all you need, right?
mhm.
You need to go to 2 pi.
That's, yeah, sometimes I will say, I might actually ask you to go from 0 to 2 pi.
Or if you had like negative 2 pi and 2 pi, you just graph in the whole thing. It doesn't specify, it's just one rotation.
Yeah, now we are going to do the from something to something because we need to see how that all plays out. Because if I was to say, give me from 0 to 2 pi, then you probably would have to graph for me something over here, see where that dot is to shift it back, right? So you might have to extend things out in order to shift them in place. Okay, well, let's try, because phase shift usually, you don't get it well, it bugs you the rest of the time here, so we're gonna spend our time with this one here. Let me have you guys do this one. Over 4, all yours for that. All right, try it yourself, and I am gonna,
Negative pi. Well, they're gonna say it's 7 pi, and I was like, what?
7 pi over 4 is what? What is that
All
in
right.
pi over 2?
that's what you're gonna figure out. So the major thing on this one is just the scale. You guys have to think about the scale along the x-axis. All right, let me start it. Amplitude is 1, not really worried about that. Period is 2 pi, not worried about that. No reflection. Minimum, maximum stays the same. So we have ourselves, if you want to just sort of write it over, PS for phase shift. Phase shift is a negative pi over 4. So this is off grid a little bit here. So this is 2 pi originally. This is pi. This is pi over 2. 3 pi over 2. There it is. There's our normal process here. 1 and -1. So if I were to graph regular old cosine, whoa. Oh. Let's see, cosine will go like here, 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 and here. Okay, this one's off by a bit. Oh. Let's see, if this was a negative pi over 2, right over here, that's about the same distance there. Pi over 4 would be this tick mark, and we can just tick mark them. So we're going to move everything over that much from the previous dot. So how about this guy gets moved over to here? This guy gets moved over to here, and we can just put some tick marks in its place, that's all. And that gets moved over to there, and again, looked crazy at first, but I think it was pretty easy. What do you guys say? Okay. Ready for this one? Ready? A little bit more complicated. Sorry, go ahead. I got two people still drawing it out.
Oh, now you're gonna put them all together.
Eventually, but one more thing before.
Then you're gonna do one with all four change amplitude.
Of course. Okay, cool. Exercise 4. I got this one here for you guys. Can you guys do this one?
Well, I think these one. And we have like a pi of 6. Which is weird.
Pi over 6, it's off. The pi over 4 is nice because it's the exact middle, right, between that one. Now I'm gonna think of where's pi over 6? How's that gonna shift things over as well? Give you guys 30 seconds start, go, and then I'll join you.
Wow.
All right, let's start it.
In one cycle, that means
One period, Period is 2 pi. All right, so let's go with it originally. That's what we wanted, the original graph here. So 2 pi, pi over 2, and 3 pi over 2. Okay, one complete cycle. And this is a minus sign, huh? So we're going to shift it over to the right this time. So let's kind of think about this here, because the way we do our sections is going to be the helpful thing. Got one there, negative one there. Okay, so if I do pi over 6, there is pi over 6. Maybe the best way to do it is in relation to pi, right? Pi would be the best one to do that. So if I have, instead of one notch, which is pi over 2, I have, or 2 notches, right, from pi over 2 to pi. I have 6 notches. So really, isn't this going to happen like this? 1, 2, 3, 4, like that? And if you want to label just a pi over 6, that's fine too. There's that label. But so I'm dividing this up into 2 pieces each time. I move it to the right, so I know I'm going to move over this much. We're good? Okay, and if we want, I keep on forgetting this here, but if you put phase shift pi over 6, just so you can have it in front of you. And then we go from there. So originally, sine would go start off at 0. It would hit the 1 here. It hit the 0 here again. It hit -1 and back to there. Oh, okay, I'll just use the same color again. So what we're gonna do is we're just gonna put a big old dot right there now. Move this over to here. Move this over to here. Here, and then yes, we're gonna move 1 over beyond that, and there it is. Whoop. Tight of a turn here. Boom, are we good there? Not bad, not bad. That was actually pretty good. Now let's get to the fun stuff here. Yep. Exercise 5. Y is equal to 4 sine of 2x minus pi over 2. All right, let's switch. And what I want is I still want to graph from 0 to 2 pi though.
So it's still graphing 0 to 2.
So just as I do it. I'm going to start it as well, and you guys just try to stay ahead of me as we go. Amplitude is 4. Period is going to be, oh, hold on. What do I have to do? I got to do something here, guys. I have to factor out. How do I factor out it? I need to factor out a 2, because remember, go back all the way to the first page of 4.3. Remember, we had the b as a multiplier. So I have to do this right here. I got to do this, and I got to figure out what's here.
Wait, so that's not actually the answer. That's not actually the phase shift.
That's not the phase shift. Let's go back real quick in our notes. Our notes, when we first started this, we have to go Yeah, the b is just sitting as a multiplier to all of this right here.
That could have be 3 pi over 4.
Oh, it's all blank. All right. Abe says it's gonna be 3 pi over 4. You guys agree, disagreed? What do you guys say? You always have to think of it backwards, right? As I multiply the 2 in, right, what's gonna happen is the 4 and the 2 reduce down to 1 and 2, and yes, I have originally what I started with. Okay, so I have my period is 2 pi divided by 2, which is pi. That's cool. I got a reflection, nope. Minimum -4. Max is +4, and I have myself a phase shift. Phase shift that says that we're gonna go 3 pi over 4 to the right. Correct? Does that make sense? All right, let's see how we get started here. So leave a little bit of space in case we need to move things. I'm still gonna have to go to 2 pi, so that's all set. That's pi over 2. And then I know I'm moving 3 pi over 4, but I have that little 4 as my denominator, right? So I'm gonna put a little tick marks.
That 2 does is change period then?
That 2 there, yeah, changes the period.
Oh, it changes.
2 changes the period, and whatever's left over there. So I'm moving this over to the right. True. Okay, so let me do this here. Without the phase shift, it would have looked like this. It's a sine curve. 1 second. 1, 2, 3, 4. So would have went like this. Would have went here, 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 and here. Now let's see how we can move things around. So that 0, 0 marker, now it becomes 3/4. That's in there. Pi over 2. So let's see how much things get moved. Once, 1, 2, 3 notches. Everything gets moved over 3 notches. We good there? So 1, 2, 3. That means this guy's here. 1, 2. Oh, hold on. 3. That means this notch would have been over here if it was graphed that way. Oh, I forgot this one. 1, 2, 3. So there's my graph here. Is that right?
But each period is within pi. Right? Not
Thank you so much, guys. Sorry.
you go on everything.
Uh-huh.
I didn't know.
Yep.
No, I realized one was perfect too, and it was like, wait a second, no, I didn't.
I messed up. Okay, there's that. Period is pi. There we go. So 1, 2, 3, 4. I'm here, here, and here. We good? And then here, here, here. And, oh. 1, 2, 3, 4. 1, 2, 3. 5, 3 pi over 2. Dun, 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 dun. There it is. Okay, are we good there for the initial graph? Okay. All right, now everything gets moved over 3 pi over 4. So this dot here goes 1, 2, 3. It gets moved all the way over here. Are we good there?
So you still go on everything.
Yeah, so still 3 tick marks over for the move. And so this guy, 1, 2, 3. So that guy gets here. 1, 2, 3. That guy gets here. This one, 1, 2, 3. This guy gets here. And when you do that one turn right there, you should be able to say, okay, based upon that, I know which way I'm going to go with things. So here, here.
Didn't you skip?
Oh, 1, 2, 3. This one right here should have been. So here, 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 and here. Oh, good. There's my one cycle. Now the question is, can I fill it in? So notice my gaps are, I'm just rotating between -4, +4, and 0, right? So that means if that's the case, that means there would have been a tick mark here. It would have been a tick mark here. And then it would have went up right to here.
Yes, it's gonna become this.
This one would be up here. It looks like a W.
So it's basically a first.
Oh, wow. It's just a cosine curve
Could have just done 4.
of 2 pi,
Yeah,
right?
2
2 pi.
Oh, we're not like
Interesting.
proving these are equal sometime later too. aren't we?
Maybe. All right. With that, we shall stop.
We did all of it first.
See again?
How far can we go in the wall?
We should be able to do all of it. We finished up the whole thing.
Last class is the lab, just so you know. Thank you, John. You
Sure, you guys. Absolutely. You guys have a great day.
too.
Thank you. Sure.